Hello, you're welcome to my today's class. In today's video, I'll be discussing density and the upthrust. Density and the upthrust. The density of any substance is defined as its mass per unit volume. So the density of any substance is defined as the mass of the substance per unit volume. So by mathematical expression, mathematically, density is equal to mass over volume, and the unit is a kilogram per meter cube, where mass is measured in kilogram and volume is measured in meter cube. Sometimes the unit may be expressed in gram per centimeter cube. Gram per centimeter cube. So, and there may be need for you to convert from gram per centimeter cube to kilogram per meter cube. If such need arises, you have to know that 1 gram per centimeter cube is equivalent to 1000 kilogram per meter cube. And what does this simply means is that if you are given a density in gram per centimeter cube and you are required to express it in kilogram per meter cube, you have to multiply the value by 1000. For example, if I have a density of 1.525 gram per cm cube, and I'm required to express this density in kilogram per meter cube, all I have to do is to simply multiply this by 1000. Therefore, we're going to have that a density of this is going to be equal to 1.25 gram per centimeter cube times 1000 kilogram per, just okay, simply say, put it this way, simply say 1.25 multiplied by 1000, and that is going to give us 1250 kilogram per centimeter cube. That is simple, right? Good. So simply multiply it by 1000, and that gives you the value in kilogram per meter cube. Now, let's take a look at a simple question here. All right. So we have a simple question here. A solid of mass 5.2 kg has a volume of 0.01 meter cube. Determine its density. A solid of mass 5.2 kg has a volume of 0.01 meter cube. Determine its volume. So, to determine the volume, the density, we have that the mass of the solid is 5.2 kilogram, and the volume V is equal to 0.01 meter cube. Then density of the object or the solid is equal to Mass over volume. Please, this is the symbol for density. That is Greek letter. This is real. Mass and volume. So that gives us our density to be 5.2 kilogram all over 0.01 meter cube, and that gives us 520 meter kilogram per meter cube. So the density of the solid is 520 kilogram per meter cube. That's simple, right? Good. All right, before we take more problems or more questions or more examples, let's look at the concept of upthrust. Upthrust. The upthrust or upthrust is a vertical upward force exerted by a fluid on any object immersed in it, whether completely or partially. Upthrust is a vertical upward force exerted by any liquid or fluid. Okay, let's get the definition. Upthrust is a vertical upward force exerted by a fluid on any object immersed in it. A vertical upward force exerted by a fluid on any object immersed in it. By fluid here, we mean either liquid or gas. But in this topic, we'll be making use of more of liquid. We'll be making use of liquid mostly here. So the vertical upward force exerted by liquid on any object immersed in it is what we refer to as what? Upthrust. Upthrust. Now, it's a common experience. Those of you that live in a rural area where you fetch water from a well, it's a common experience that when you are fetching water from a well and you have your fetcher immersed in the well, while the fetcher is filled up with water and it is still deeply immersed in the well, while you are lifting it, the weight appears less. But immediately it comes out of the water, it becomes heavier. The reason for this is because when the solid is immersed in water, or when the fetcher is immersed in water, the upper part of the fetcher experiences different pressure as the lower part. So this difference in pressure reduces the weight of the object as it is in water. So as you lift it up, this difference in pressure provides an additional upward force to add to the one you are using to lift it, making the weight to be lesser. Immediately the substance leaves water. That additional pressure, additional force leaves it. Then the object weighs what? Higher. Is that clear? So with that definition, we can simply say that if I have a spring balance used to measure the weight of an object, so I have a spring balance which measures the weight of objects, and I have a load attached to the scale pan or to the spring balance. We have a load. Now the weight, remember the spring balance is calibrated to record weight directly. So each of these calibration has its number written by the side. So when you hang a load here, the spring pulls down a pointer and the pointer moves down to indicate the exact weight of the load you have added. So the weight is indicated on the pointer. Now, if I'm to carry this on the spring the way it is and completely immerse it in a liquid, you're going to notice that when this is immersed in a liquid, the reading on the spring balance will change. So the reading tends to be higher when it is not yet immersed in water than when it is immersed in water. So when it is immersed in water, the reading decreases. So this difference in value is the upthrust. So with that, we can say that upthrust is equals to the weight of an object in air minus the weight in a liquid. The weight of an object in air minus its weight in a given liquid. So that is upthrust. The weight of the object in air minus the weight in a given liquid. Are we good? All right. Let's look at another simple problem. Okay, we have another simple question here. A metal block weighs 50 Newton in air and 35 Newton when completely immersed in water. Determine the upthrust on the block. A metal block weighs 50 Newton in air and 35 Newton when completely immersed in water. Determine the upthrust on the block. So what do we do here? Solution. From our definition there, from our formula we stated earlier, upthrust is equals to the weight in air minus weight in water, and that will be equal to 50 Newton, which is the weight in air, minus 35 Newton, which is weight in water, and that gives us what? 15 Newton. So the upthrust on the what? Solid is on the block is 15 Newton. That's simple, right? Good. Let's go. Still on the upthrust. Now, let's look at this upthrust on a different aspect. You see, when you immerse a solid in a liquid, you notice that the level of water in that container tends to rise. The reason is that the solid you have immersed displaces some water molecules, and those water molecules it displaces comes to the surface, leading to a rise in the level of the liquid. Now, the volume of liquid displaced by that solid is actually equal to the volume of the solid. So with that, we can also look at the upthrust on a different aspect. So recall that we have already defined our density to be equal to mass over volume. If I make this mass the subject, I have that mass is equal to density times what? Volume. Are you with me? Now, for the object, the weight of the object, remember weight is equal to mass times acceleration due to gravity. And already the mass is this density times volume. We can therefore write this to be what? Density times volume times acceleration due to gravity. So the weight of the solid immersed in the liquid is equal to the weight of liquid displaced by the object also. In that case, we can have that upthrust can also be given as density times volume times acceleration due to gravity, where this is equals to density of the liquid. Density of the liquid, V, is volume of liquid displaced, and G is acceleration due to gravity, which is constant. This is G is 10 meter per second square, or 9.8 meter per second square. So that is another way you can calculate your upthrust. Density of the liquid times volume of the liquid times acceleration due to gravity. So this the volume of liquid displaced here. Please take note. Now let's look at another question on that. All right, let us look at this question from JAM. This is one of the questions from JAM past question. It's also as simple as every other questions we have been solving. A meter cube of side 0.2 meter suspended on a string balance on a string is completely immersed in water of density 1000 kilogram per meter cube. The upthrust on the cube is what? So now, for us to determine the upthrust, solution, we have to know that since when the metal cube is immersed in water, it will displace some water molecules. So the weight of water displaced will be equal to the weight of the cube. Also, the volume of liquid displaced will be equal to the volume of the cube. Very important here. So in that case, we have that we need to get the volume of cube. Volume of cube is the length raised to power 3, and that will be equal to 0.2 meter r raised to power 3, which is 0.008 meter cubed. Now this is the volume of the metal cube. Density of water is given as 1000 kilogram per meter cube. And again, don't forget, you see, in as much as acceleration due to gravity is not mentioned here, don't forget it has to be there. So G is 10 meter per second square. Remember, it is constant. Always use it as 10 unless it is specified as 8, 9.8. Use 9.8 or 10. They are approximately equal. Therefore, this upthrust is equals to the density of the liquid times the volume of liquid displaced, which is here, times what? Acceleration due to gravity. And that will be equals to the density is 1000. The volume of liquid displaced is equal to the volume of the cube, and that is equal to 0.008 times 10. And this is acceleration due to gravity. So this will give us 80 Newton. 80 Newton. So the upthrust on the cube is 80 Newton, right? All right. Let us look at another simple question, just as simple as the previous ones we solved. a plastic of mass 2.5 kg and density 0.25 kilogram per meter cube floats in water with 1/3 of its volume immersed in water. Calculate the upthrust on the plastic. So you have to also know that the volume of liquids that will be displaced by the plastic will be equal to the volume of the plastic that is immersed. So first of all, we need to know the volume of the plastic. I remember the question says half 1/3 of its volume was immersed. So first of all, we need to determine what is the original volume, the total volume of the plastic. Then we now find 1/3 of it, which is the part that is immersed in water. So recall that density is mass over volume. And we are given the density of the mass and the density of the liquid, but the volume is not of the plastic, but the volume is not given. So we need to calculate the volume. Here, volume is equal to mass over density. And that will be equal to, the mass is 2.5 kilogram over density 0.25 kilogram per meter cube. So when we do that, this is going to give us 10 meter cube. So the volume of the solid is 10 meter cube. So upthrust on the plastic is equal to the density of water multiplied by the volume of water displaced. Not actually the volume of the solid, but the volume of water displaced by the plastic, then times acceleration due to gravity. You see, yes, with this now, we can substitute our value. The density of water is given as 1000 times the volume of water displaced. Remember, it is 1/3 of this that is a mass. So the volume of water displaced is 1/3 of this, which is 1/3 times 10, then again times acceleration due to gravity, g, which is 10. So this gives us 100,000 over 3. When we divide this, it's going to give us 3.3, sorry, 3.3 Newton. So the upthrust on the plastic is this. That's simple, right? Good. All right, we've come to the final phase. To the final phase of density and upthrust. Now we're looking at relative density. So on the relative density, we have to know that relative density of any substance is the ratio of the density of the substance to the density of water. The ratio of the density of the substance to the density of water. That is what I gives us for relative density. Density of water is actually 1000 kilogram per meter cube, or 1 gram per centimeter cube. So that is the density of water. And water has a relative density of what? 1. It has a relative density of 1. All metals have relative density that are greater than 1. Why most non-metals and some liquids have relative densities that are less than 1. Have relative densities that are less than 1. Most of metals and the liquids. All right. Now we simply say that relative density is equal to density of a substance all over density of water. Please, we are not going to limit this our definition to here alone. We also have that we can obtain the relative density of any substance using the formula Upthrust in the weight in air all over weight in water. So we calculate the relative density by using the formula the weight of an object in air divided by its weight in water. So when we mass it in water, it will experience an upthrust, so which gives it a different weight. So the weight of the object in air divided by the weight in water can also give us what? Relative density. Then when we have a liquid, we can also measure the relative density of a liquid in a different way. By getting a solid, we mass a solid in the liquid and determine the upthrust of the solid in that particular liquid. And also we immerse it in water and get the upthrust in water. So in that case, we can also have that relative density of a liquid is equal to upthrust in the liquid all over upthrust in water. So simply get any solid, immerse it in the liquid and get the upthrust. Then immerse in water and get the upthrust in water. So the ratio of the upthrust in the liquid to the upthrust in water will give us the relative density of the liquid. All right. So let's look at let us look at another simple problem from JAMB past question. This is one of the JAMB questions. And it's just as simple as the previous problems we have solved. A solid weighs 10 Newton in air, 6 Newton in water, and 7 Newton in a liquid X. The relative density of the liquid is what? So like I said earlier, now remember this question is emphasizing purely on relative density of the liquid X. So let's look at what we have to do here. Remember, we said that when this object is immersed in a liquid or in water, it will experience upthrust due to water. If you also immerse it in a liquid X, it will also experience an upthrust due to the liquid. So we're able to explain that relative density of such liquid will be its upthrust in the liquid divided by upthrust in water. Okay, please let me use upthrust in X since the liquid is X divided by upthrust in water. But recall from the previous lesson that upthrust in X is equal to the weight of the solid in air minus its weight in the solid X, right? Also, the upthrust experienced when it is immersed in water is also the weight in air minus weight in water. Here, we're going to have 10 minus 7 because the weight in water is 10 and the weight in X is 7, and that gives us a 3 Newton. And this is 10 minus 6, which gives us a 4 Newton. So with that, we have that relative density of the liquid is now the upthrust in X, which is 3 Newton, all over the upthrust in water, which is 4 Newton, and that gives us 3/4. And the answer to this question is 3/4. That is very simple, right? Please do ensure to click on the like button and share with your friend. To get a full video or a full teaching or detailed teaching on this topic, click the link on the comment section. You subscribe to my YouTube channel for you to get few videos. If also there is any topic you would want